Hello students, we can start with our first module, which is linear algebra. First, we have to know what is linear system of equations. We know that a linear system of equations is a collection of two or more linear equations involving the same set of variables. Solving this system is fundamental in engineering because they model a wide range of practical problems involved in electrical circuits, structural analysis, fluid dynamics, and economics, etc. Linear systems are generally represented by using matrices which make the system easy to handle and to solve efficiently. We can say that a general form of linear system, which is represented in here, we can write it as a coefficient matrix and a variable matrix and a constant term. We can represent an equation like that: a11 x1 plus a12 x2 plus etc. a1n xn equal to b1. Like that we can represent n number of equations: am1 x1 plus am2 x2 plus etc. amn xn equal to bn. We can represent this linear system of equation in a matrix form. Like that, A is a coefficient matrix which is a11, a12, etc. a1n, and it has m number of columns and n number of rows. So, X is a variable matrix and B is the constant matrix. So, we can represent this linear system of equations in a matrix form: Ax equal to B. Then these matrix A and B jointly we can say that augmented matrix. It is represented like that. The coefficient matrix is represented like the same and the constant matrix represented in the last column. So A11, A12 up to A1n and last element is B1. Like that, the last column is the same matrix of B. So this matrix is known as augmented matrix. Then we are using two type of equations for solving this linear algebra, and here if Ax equal to 0, that means our matrix Ax equal to B. B is a 0 matrix. We can represent it as Ax equal to 0. That means B is 0. This equation is known as homogeneous equations. These homogeneous equations have trivial solutions. And next, if Ax equal to B, if B matrix contain any non-zero element, we can say that it is a non-homogeneous equations. In non-homogeneous equation, we are using Gauss elimination method. Next, how we can solve this Gauss elimination method? We can solve the linear system of equations using Gauss elimination method. Our question is that solve minus 3x plus 8y equal to 5 and 8x minus 12y equal to minus 11. This is our equations. We have to solve this using Gauss elimination method. So first we have to represent it in a matrix form: Ax equal to B. Then A matrix is the coefficient of these equations: minus 3, 8 and 8 minus 12. This is A matrix. X is our variable matrix which we have x and y. We can represent it as x and y or x1 or x2. Equal to B is our constant matrix which is 5 and minus 11. Then we have to write the augmented matrix which is AB. Augmented matrix, the matrix is same as A, then last column will be the B matrix. So this is our augmented matrix. Next we have to convert it into a row reduced form. To row reduced form, to know that we have to first know the diagonal elements. The diagonal elements are these are the diagonal elements of the matrix. We have to convert the elements under the diagonal elements must be 0. So for that we have to, these are our diagonal elements. So we have to convert the elements under the diagonal elements to 0. So we have to convert 8 into 0. So to convert that we have to convert this matrix into row reduced form. For that this is the R2 row, this is the first row R1 and this is the second row R2. So we have to convert the R2 matrix, R2 row into this. To make this element 0, we have to do this calculation 3R2 plus 8R1. That means 3R2, that means 3R2. R2 means this element. We can write it as R2 is here, R2 converting to, that means 3R2 plus 8R1. Here 8, R2 is the first element, 8. So 3 into 8 plus 8 into R1 minus 3. So this will, first element will be 8 into 3, 24, minus 8 into 3, 24, it will be 0. So we have converted this element to 0. Similarly, we have to convert this element also into, using this equation. So next element will be minus 12. So minus 12, 3 into minus 12 plus 8 into R1, 8. So the element will be, we will get the element 28. Similarly, we have to do this for the third element also. So 3 into R2. R2 is minus 11 plus 8 into R1. R1 is 5. Here we will get 7. So according to that, we are converting this matrix into minus 3, 8, 5. This is the same. And the last row changed to 0. We get 0, 28, 7. 0, 28, 7. So we get the row reduced form. That means we are converting the element which is under the diagonal elements to 0. So here we got this element matrix, and here we are writing by back substitution to equation form. So minus 3x1, 8x2 equal to 5. Then next element, it will be 0. So 28x2 equal to 5. From this we will get x2 equal to 7 by 28, which is equal to 1 by 4. And also we can substitute x2 in this equation, we will get x1. Here we will get x1 equal to minus 1. Here we are doing the calculation like that. If we have to convert the row reduced form, we are doing the element which is under the diagonal elements. This is the diagonal elements, and under this diagonal elements, what are the elements under this diagonal elements must be 0. So for that we are doing row reduced form. According to that, we can convert our row into to make this element to 0, we can convert this element row. Here we are doing here that using these diagonal elements, we are converting the other elements into 0. Using these diagonal elements, we are converting these elements which is under the diagonal elements to 0. This is the calculation method here we are doing.